Okay, energy and chemical and physical changes. Chemical and physical changes are generally accompanied by energy changes. When water evaporates, there's an energy change. When natural gas burns, there's an energy change. When we have the release of energy in a chemical reaction, such as the combustion of natural gas, it is similar to the transformation in which something with high potential energy, such as this 10-kilogram weight, teetering on the edge of this building, is unstable, and when it's knocked down, it falls, and its potential energy is turned into kinetic energy. So the release of energy during a chemical reaction, you've got the stored potential energy in the compound that gets released when the chemical change occurs. Now, when this weight hits the ground, it had transferred its potential energy into kinetic energy, and it's going at maximum velocity when it hits the ground. Now what happens to all of that kinetic energy? It gets absorbed by the pavement. It gets converted into heat energy. Now, you may not notice that, but if two things have a very big collision, there's heat that's generated by that. So the energy isn't lost, but it's transformed into another form. This heat energy is generally not useful, and so it appears to be lost. It's lost to being useful, but it's not that it has disappeared. It's just no longer very useful. So things with high potential energy are unstable. Things with low potential energy are stable. And so things tend to go from high potential energy and transform to low potential energy, and that's just the nature of nature. Kind of said that already. Some chemical substances, like TNT, have high potential energy. There's energy that's concentrated in them, and they will undergo rapid chemical changes that release that energy, lower their potential energy, and that's why TNT is explosive. It has a lot of stored chemical energy. And when that's released, you have this tremendous release of energy, and that's an explosion. So the energy change, the energy can either be released or it can be absorbed in a chemical reaction. An exothermic chemical reaction, exo is like exit, it's going out. Thermal refers to energy, or thermic. Exothermic means that energy is going out of the reaction. So for an exothermic reaction, we start with a high potential energy and we go to a lower potential energy. And the energy is released to the surroundings. Endothermic, endo is like the word into, means going in. So endothermic means energy is absorbed. So you can have an endothermic reaction where you have reactants at low potential energy and they will absorb energy from the surroundings and end up at higher potential energy. And these sorts of reactions are typically not as spontaneous as exothermic reactions. So let's identify each of these changes as exothermic or endothermic. So water freezing into ice. Does that process release energy or absorb energy? That's hard to think about, isn't it? Yeah, so think about ice. If it absorbs energy, if you, say, put it in a saucepan on the stove and turn the heat on and put energy into it, does that cause it to freeze? No, that causes it to melt, right? So this is the opposite process of melting. If melting is absorbing energy, then freezing must be releasing energy. It's kind of hard to think about. That's exothermic. So how do you get water to freeze? If you want ice cubes, what do you do at home? You put water in the freezer, right? Because the freezer's cold. How is the freezer cold? Have you ever thought about that? It's not magic. It's science. So there's a compressor and a pump and fans, And what it does is it's sucking the heat out of the inside of your freezer. So you put water in there, room temperature, and the freezer sucks energy out of it. This isn't something that just is going to happen spontaneously at room temperature, but in the freezer it will. And so water freezing is an exothermic process. It gives off heat. That one's kind of hard to think about. Sometimes with these transitions, if you think about the opposite, it's easier, and then you can just reverse things. What about natural gas burning? Is that releasing energy or absorbing energy? It's releasing. So you think about a natural gas flame, it's hot, right? Where's the hot come from? That was stored in the natural gas, and through the combustion reaction, it's releasing that energy as heat into the surroundings. So that's also an exothermic reaction. Any questions?